Hello everyone, hope everyone is fine and doing good. So what's update? Well, update is this is gonna be the 17th video of kinematics video lecture series, and in this video we are going to discuss the concept of horizontal projectile from certain height from the ground. We will solve some question and we will see how we can use the equation of trajectory to solve these all problems. So let's get started. When we talk about the horizontal projection of a projectile from certain height from the ground, then it simply means that the angle of projection with the horizontal direction is equal to 0 degree. What about the angle with the acceleration vector? Well, for this we can see, suppose if this is certain height h from the ground, and let's assume this is any object which is thrown at certain speed u, and we already know the acceleration vector acts in vertical downward direction. So from this figure you can say that the angle between initial velocity vector and the acceleration vector is equal to 90 degree, right? So for horizontal projection we have the angle between acceleration and initial velocity vector is equal to 90 degree. So for this, what will happen to the motion of this particular object over here? So you can notice that because of this angle, the particle takes this path, which is nothing but a parabolic path, right? And why does it happen? We already discussed in previous videos. So this is the projectile path, or we can say this is a parabolic path. Now if you see this u over here, this is nothing but the x component of velocity, right? So we can say that initial velocity is nothing but the x component of velocity. What about the vertical component of velocity over here? So you can say uy is equal to 0, right? So let's take a look on these components. So here we have ux and uy is equal to 0, and we already know that when we study the projectile motion there is no component of acceleration along the horizontal direction. So that simply means that ax is equal to 0, and here we have ay equal to minus g. Why it is minus g? Because by convention we take the vertical downward direction is to be negatively signed, right? So we have these two sets of equation. Now we can say if we have acceleration along the x direction is equal to 0, then we can say velocity along x direction remains same for all the time. Okay, what about velocity along y direction? So here we can notice, here we have acceleration that is minus g, and that is acting in vertical downward direction. So because of this acceleration we can say that the velocity of the projectile along y direction keeps on changing. But what about the initial velocity along y direction? Here it is 0. So by using this equation, vy is equal to uy minus gt, we can find out the velocity of the projectile along y direction at any time t, right? So now let's take a look on how we can derive the equations of time of flight and for this particular horizontal distance. So let's assume this distance is d, and here we have time of flight is capital T, and let's assume here we have this point is b, and this point is a, and this point is o. So now let's take a look on next how we can find out the expression for time of flight and horizontal distance. So first let's derive the expression for the time of flight, and we can say the time of flight is the time taken by the projectile to hit the ground, right? So here within this time t, what happens basically? The projectile travels this vertical height h, and it is in vertical downward direction. So by convention we can say the particle travel this minus h vertical distance, and it is equal to ut minus half gt square. So basically what I have done, I have just substituted one of the equation of uniformly accelerated motion. So based on that we can say this is the equation, and What about this u? This is nothing but the y component of velocity. So here we can say this term is equal to 0, because this is nothing but the y component of velocity, right? And what is the component of acceleration along vertical direction? This is minus g. Okay, so here if we rearrange the equation, then this t is equal to twice of h upon g. So this is nothing but this is the time of flight. Now, based on this time of flight, we can calculate this horizontal distance d. So for this, what we can do, d is equal to u into t, and this is u into twice of h over g. So this is nothing but we can say this is the horizontal distance traveled by the projectile. So basically what we have done, we have used the basic formula, distance equal to velocity into time. And what is the velocity here in this case? This is u only. And we already know that it is the constant for all the time. So this horizontal distance can be found out by just taking the product of velocity and time. Now let's take a look on how we can derive the equation of trajectory for this particular case. We already know that equation of trajectory is nothing but the relation that connects x and y components of position of a projectile at certain time t. So for this, we should have the equations of x and y positions of the projectile. So here we have x is equal to ut, and y minus y is equal to uyt minus half gt square. And we can see here we have this negative y. Why it is? Because this is as per the standard sign convention, right? Because we generally take the vertical downward direction is to be negatively signed. Okay, so here we have these two equations, and by using this equation I can say this time t is equal to x over u, and I can put this time t equal to x over u into this equation. So from here I can say this minus y is equal to 0 minus half g x square upon u square. So it will give me y is equal to g upon 2 u square into x square. So this is nothing but the equation of trajectory. And again you can see we have here x square. So what does it mean? This is the equation of a parabola, right? Now here you can see why I have taken this uy into t equal to 0, because we already know this is the case of the horizontal projection. So for this case we have uy equal to 0, right? So this is the equation of trajectory. Now let's take some questions of this type of projectile, and we will solve the questions of this kind of projectile by using this equation of trajectory, and we will solve the question by using the standard methods as well. So here we have this question. A particle is thrown horizontally from certain height h from ground with velocity 20 meter per second. If projectile takes 5 seconds to hit the ground, then find out height of projectile and the distance where the particle hits the ground. So first of all, let's draw the diagram. So here we have this is a certain height h, and the particle is thrown horizontally with speed 20 meter per second, and the path taken by the projectile is like this. So let's assume this is any point b, this is any point a, and here we have this point is o. Now we have to find out what? We have to find out this height h and this horizontal distance d. By using equation of trajectory, we can find out these two parameters. So here we have y is equal to 1 over 2 g upon u square into x square. We don't have any information about y and x, but yeah, we know what is the value of this u. So here it is u equal to 20 meter per second. So let's plug in this value over here, and let's take g is equal to 10 meter per second square. So if we substitute it over here, then we can say it is 5 over 20 into 20, and this is x squared. After simplifying this expression, we get this y is equal to 1 over 80 into x square, and let's assume this is equation 1. We need to find out the value of this x, and we can find out by using this equation. X is equal to u into t. What is this u? This is the horizontal velocity over here, and this t is nothing but the time of flight, and here it is given as 5 seconds, right? So let's plug in the values of u and t over here. So after substituting these values, this will give me 100 meter. Now let's plug in this value of x over here. So after substituting the value of x into this, we get the value comes out to be y equal to 125 meter. So 125 is nothing but the height, this height, and this horizontal distance is equal to 100 meter. So this is the solution of this particular question. Now let's take a look on other questions. So here we have this question. A ball is thrown horizontally from a tower of a known height h meter with speed 20 meter per second. After some time, speed of ball was found 20 under root 2 meter per second. In next 3 seconds, the ball hits the ground. Calculate height of tower, horizontal distance, time of flight, and height of ball at speed 20 under root 2 meter per second. So for this, first let's draw the diagram of this projectile motion. So here we have this vertical height h. This is basically the height of the tower, and let's assume this is the ball which is thrown with speed 20 meter per second, and under the effect of this gravity alone, the ball takes this parabolic path, right? And here we have a point P at which the speed of the ball is found to be 20 under root 2 meter per second, and the time taken by the ball to acquire this speed, it is given to us time t equal to, this is how much it is actually. Okay, it is not given actually, right? So this is the quantity which we have to find out. And after this point P, the time taken by the projectile to hit the ground, it is given to us time. Let's assume this is t2 equal to 3 seconds. So total time of flight t can be written as t plus t2, and let's assume this is t1. So here we have t1. So this is what the expression of time of flight. After finding out the value of this t1, we can find out the value of this time of flight. Now here what we can do, let's write down all the formulas which we have derived. So here we have time of flight is equal to twice of h upon g under root. So this is the expression of time of flight, and we already know equation of trajectory is g upon 2 u square multiply with x square, and this x is equal to u into t, and velocity of the projectile at certain instant of time, it is vx square plus vy square. Now let's see how we can calculate all these quantities one by one. So first let's use this important information, the speed of the ball at this particular point P. So we can write down this as v is equal to vx square plus vy square, and this value is 20 under root 2. So let's do the squaring of both these two sides. Then from here we can obtain vx square plus vy square. What is this value vx square? It is given to us 20 meter per second. So let's plug in this value over here. After substituting this value, then we can say vy square is equal to, it is 800 minus 400, and vy comes out to be 20 meter per second. So this is the y component of velocity at this particular point. So here we have Vy equal to 20 meter per second, and if I use this equation Vy is equal to Uy minus Gt, by using this equation I can find out the time, basically this time t1, right? So here we have this t1, and t1 is equal to 40 upon 10, so it will give me 4 second, right? Basically what you can do, you can substitute it here, this Vy with negative sign, because the velocity is in the negative direction. Okay, so here we have found out the value of this t1. Now we can say this time of flight is nothing but it is equal to 4 plus 3, so this is nothing but time t equal to 7 seconds. So this is what the time of flight. So the next task is to find out the height of the point at which the speed of the projectile is 20 under root 2 meter per second. So basically we have to find out this vertical height, which is represented by this blue line. So for this what we can do, we can apply equation of trajectory over here. So let's write down. So this is y is equal to g upon 2 u square, and it is multiplied with x square. So for this we should have the value of this x, and for this we can apply x is equal to u into t, and we apply this equation for time t equal to 4 second. Why? Because it is the time taken by the projectile to come at this point P, and we have already calculated over here. So this t1 equal to 4 second. So let's plug in this value over here. So this x is equal to 20 into 4, and it will give me 80 meter. After substituting this value into this, then we obtain this is y is equal to 10 upon 2. U is given to us, that is 20 meter per second. So this is 20 into 2, and here in the denominator we have 80 into 80. So after solving, this value comes out to be 80 meter. So this height is equal to 80 meter. So that's all for today, and I will see you in my next video when I will be discussing the projectile on an inclined plane. And if you have any doubt, then you can reach out to me in the comment box, then definitely I will be replying back to you all. So I will see you soon in my next video. Until then, keep watching and stay connected for further updates.